Hello everyone, welcome to our Git and GitHub AWS CodeCommit crash course. In this video, we will delve into the fundamentals of Git and GitHub CodeCommit, covering what is Git, its significance, the distinction between Git, GitHub, CodeCommit, the installation process, and a hands-on walkthrough of commonly used Git commands. We will explore repository creation, branching, merging, reverting changes, working with local and remote Git repositories, and some essential GitHub CodeCommit operations. Whether you are an aspiring developer, DevOps engineer, or looking to streamline your coding project, you have come to the right place. Join me for a comprehensive tutorial session that combines both theory and practical aspects. Before we dive into today's tutorial, let me take a moment to introduce myself. My name is Ojasvi Jagtap. I am DevOps and AWS Cloud Engineer with over 15 years of hands-on industry experience. On this channel, I explore topics ranging from DevOps methodologies to cloud technologies and even touch on maintaining a healthy work-life balance in the tech world. I am excited to share that I have recently launched a dedicated playlist focusing on widely used and popular tools in the software industry, especially for DevOps. Make sure to check out the playlist for valuable insights and in-depth tutorials. Connect with me by dropping a comment below or find me on LinkedIn for more updates. If you find this tutorial helpful, show your support by giving it a thumbs up, subscribing for more content, and sharing it with your network. Let's start at the very beginning. What is version control system, or VCS? In simple terms, version control system is like a time machine for your project. It helps you keep track of changes made to your files over time, allowing you to go back to previous version or see how things have evolved. This is particularly useful when multiple people are working on the same project, as it ensures the smooth collaboration by managing changes, avoiding conflicts, and maintaining a clear history of project's development. Let's elaborate on the concept of tracking changes in the context of writing a story in a notebook. Imagine you are writing your story in a notebook. As you progress, you make various edits, additions, or revisions. Tracking changes means keeping a detailed record of every modification you make to the story. This includes noting down the date, time when each change was added, as well as the specific nature of alteration, whether it's adding new paragraph, deleting sentence, or rephrasing sentence for clarity. For example, if you decide to remove a page from your notebook because you feel it doesn't fit well with the overall narrative, tracking changes ensure that this action is recorded. Similarly, if you decide to rewrite a section of your story to improve its flow, tracking changes document the precise alteration made, allowing you to revert back to earlier version if needed. In essence, tracking changes provides a comprehensive history of the evolution of your story, allowing you to monitor the progression of your writing, identify specific edits or revisions, and maintain a clear record of creative process. This ensures transparency, accountability, and the ability to collaborate effectively with others, as everyone involved can see the timeline of the change and understand the reason behind each modification. Some popular examples of version control system includes Git, Subversion known as SVN, Mercurial, and Perforce. However, Git stands out as the most popular one in the modern tech era. We will shortly explore why Git has become a go-to choice for many developers and organizations. Git is a powerful and widely used version control system that revolutionized the way developers collaborate on software projects. In the notebook analogy, Git serves as the magical tool that automates and streamlines the process of tracking changes to your story. Instead of manually jotting down every edit and revision, Git handles this process seamlessly in the background, much like a diligent assistant. When you start your project, you initialize Git and mark it as starting point of your development journey. Just as you would make changes to your story in the notebook, you make modification to your code in your development environment. As you continue working on further changes, each set of modification is added to Git as well, creating a series of snapshot or versions that captures the progress of your project at different stages. Now, here is where Git truly shines. When you're ready to introduce new feature, bug fixes, or implement improvements, you put these changes into Git, updating the project's history. Git seamlessly manages these updates, ensuring that every change is documented and traceable. If you ever need to revisit previous state of your project, Git allows you to do so seamlessly, providing a reliable and comprehensive record of your project's evolution over time. In essence, Git serves as a collaborative time travel tool for your project, much like Magical Notebook does for your story. It not only allows you to revisit previous states of your project, but also enables a structured, efficient workflow where change is documented, providing transparency, accountability, and the ability to collaborate effectively with others. This ensures the integrity of your project's history and helps team work together seamlessly, just as it does for writers collaborating on a story. One of the Git's key strengths is its distributed nature, meaning each contributor has a complete copy of the project's history, not just the latest version. That means contributor can work on their copies independently, even without an internet connection. It allows developers to work more independently, contributes to faster operations, and ensure a robust version control system, even in situations where internet connectivity may be limited or intermittent. Git's distributed nature is a key feature that sets it apart from traditional version control systems. What makes Git even more appealing is that it is a free and open source version control system. This means not only it is accessible to everyone, but the community actively contributes to its improvement. In addition to its efficiency, Git has become the industry standard for open source projects and is widely adopted in professional software development. Its popularity is attributed to its speed, flexibility, robustness, and powerful set of tools it provides. Git uses a branching system, enabling developers to work on new features or fixes without disrupting the main project. The ability to merge these branches back together facilitates smooth collaboration. Whether you are a solo developer or part of a large team, understanding Git is a skill that enhances collaboration, tracks changes effectively, and ensures the integrity of your project's history. As we dive into this series, we will unravel the magic of Git and explore its practical applications in software development. Before we explore where these tools fit, let's expand our list with few more examples of similar platforms like GitHub. These includes GitLab, Bitbucket, Azure DevOps, and AWS CodeCommit. These platforms are referred to as version control hosting service or repository management platforms. They are often described as tools for hosting Git repositories, facilitating code collaboration, and managing software development projects. Depending on the requirements and technology stack set, individuals or organizations have the ability to select a repository management platform from the available options that best align with their specific needs. To enhance clarity, let's illustrate this concept further with the context of our notebook analogy. Imagine you have filled up your notebook with your story and now you want to share it with others or collaborate with fellow writers. This is where platforms like GitHub, CodeCommit, and Bitbucket come into play. GitHub, CodeCommit, and Bitbucket act as a library or repository where you can store your magical notebook representing your Git repository and share it with others. Just as you would upload your story to these platforms, you can upload your code and complete with all its revision and versions to these repository management platforms. Just as you would upload your story to these platforms, you can upload your code complete with all its revisions and versions to these repository management platforms. Once your code is uploaded to GitHub, CodeCommit or Bitbucket, it becomes accessible to anyone with an internet connection and proper authentication. Others can read your code, make suggestions, or even contribute their own additions or modification to your project, just as they would with your story in shared library. These repository management platforms also provide additional features and functionality to enhance collaboration. For example, they offer tools for reviewing code changes, managing project tasks and issues, and facilitating communication among team members. This makes easier for multiple developers to work together on same project, much like writers collaborating on a story in a shared library. In essence, GitHub, CodeCommit, Bitbucket serve as centralized hub for storing, managing, and collaborating on projects stored in Git repositories, much like a library serves as a central location for storing and sharing books. This provides a platform for developers to work together, share ideas, and contribute to each other's project, fostering a vibrant community of collaboration and creativity, similar to writers collaborating on stories in a shared library. In short, Git is a tool you can use on your computer to track changes and collaborate locally, and GitHub or CodeCommit or Bitbucket is the platform where Git repositories can be stored, shared, and collaborated on with others. Now let's start by setting up Git on your local machine, followed by working with GitHub and AWS CodeCommit. Before we proceed, I want to mention that all the commands and links I will be using in this tutorial are conveniently compiled in a downloadable document. You can find the link to downloadable document in the description below. For a comprehensive understanding and hands-on experience, I highly recommend you following along with me step by step on your workstation. The first step is to install Git on your workstation. In this tutorial, I will guide you through the installation process for both Mac and Windows operating system. You can download Git from git-scm.com download. Click the download link for your specific operating system and then follow through the installation wizard to get things set up on your computer. Let's start with Mac installation first, and then we will install Git on Windows. I'm gonna use brew to install Git on my MacBook. So I'm gonna copy the command and go to Mac terminal and paste it in there, and it will start the installation. After installation is done, type the following command to verify that Git is ready to be used on your computer. If everything went well, it should return the Git version that is installed on your computer. Now let's start with Git installation on Windows, and I'm again on gitscm.com downloads, and this time I'm gonna follow the instructions for Windows installer. I will click here to download the latest 64-bit version of Git for Windows, and it will start the download, and then I will follow through the instructions. So I'm gonna say next. It will install it under program files Git. I'm gonna check the checkbox for on the desktop and then say next by keeping rest of the options as default. On this screen, you can choose editor of your choice. There are options available. However, for now, I'm just gonna go with the default editor, which is Vim. I'm keeping default option, and here I'm gonna choose use Git and optional Unix tools from Windows command prompt. and press next, next again, next, next. I'm just going with default options, next, and install. The installation will take some time, so I'm gonna pause till installation is finished. Git installation has been done, so I'm gonna click on the finish. And once installation is completed, you can start your Git bash by typing Git bash on Windows search. You can verify that Git command line tools were properly installed by typing git --version in Git bash, and it will return the current installed version on your Windows if installation was successful. After installing Git on your local machine, the next step is to configure it with your personal information. This includes setting your name and email address, which will be associated with your Git commits. You can configure Git by opening terminal or command prompt window on your local machine and running following commands by replacing your actual name and email address. And the command is git config --global user.name, your name, and second command is git config --global user.email and your email address. You can verify that Git has been configured correctly by running git config --global --list. This command will display a list of all your global Git configuration settings. When working with Git, it's important to be familiar with the term repository. A Git repository is essentially a folder or directory on your computer that contains all the files and folders related to a particular project. However, what sets it apart is that it's actively tracked and managed by Git, the version control system. This means that every change made to the file within the repository is recorded and managed by Git, allowing you to keep track of the project history, collaboration with others, and revert to previous versions if needed. Once Git is installed and configured on your local machine, you can initialize a new Git repository for your project. Navigate to the root directory of your project using terminal or command prompt. So I am at the root of my project and I intend to create my new repository under this project directory. To initialize new repository, run git init command. This command initiate an empty Git repository in the current directory. This command will generate a hidden .git directory for your project where Git stores all internal tracking data for the current repository. To verify that the repository has been initialized correctly, you can run git status command. The git status command is a fundamental tool used extensively in Git workflows. It provides valuable insight into current state of your repository, including information on which files have been modified, which files are staged for commit, and which files are untracked. Before we proceed further, let's explore the concept of staging in Git. Imagine the staging area in Git as a preparation zone before capturing a snapshot of your project. When you make changes to files in your project, Git doesn't automatically include them in your next snapshot, that means commit. Instead, you decide which changes to include by adding them to the staging area. It's similar to deciding which items to pack for a trip before placing them in your suitcase. Once you are satisfied with the selection in the staging area, you can commit them, effectively capturing a snapshot of your project at that specific moment. This approach allows you to organize and control what gets included in each commit, resulting in a more manageable and organized project history. Now let's create a new file and add it to the staging area, which allow it to be tracked. I am currently at the root of my new repository. To add a new file to root directory of our repository, let's stay in this directory and create a new file using text editor or by using touch command followed by desired file name. To stage newly created file, we'll use git add and new file name command. To verify that the file has been successfully added to the staging area, you can use git status command. This command will display the current status of the repository, showing the newly created file under the changes to be committed section. Now the new file has been created and added to the staging area in your Git repository. You can proceed to commit the changes using git commit command. Committing in Git is like taking a snapshot of your project at a specific moment in time. It's a way to save changes you have made to your files and create a checkpoint that you can refer back to later if needed. Once you commit your changes, Git records them permanently in the project's history. You can always go back to that point if something goes wrong or if you want to see how far you have come. Now let's proceed with committing the staged file, and for that we will use git commit command to create a commit with those changes. We will use git commit command to commit changes which we have staged. So the command is git commit -m and your commit message. It's always good to add brief description of the change you are committing. This message helps you and others understand what this commit is about. That's it. We have successfully committed our first change to the repository. Now these changes are saved in Git's history and we can refer back to them whenever needed. Until now, we have been operating within our local Git repository. It's time to delve into the concept of local and remote repositories. In simple words, think of your local repository as your personal workspace where you make changes to your project on your computer. It's like your desk where you jot down notes, make edits, and organize your work. You can work on your local repository even without an internet connection using locally installed Git. On the other hand, the remote repository, often hosted on platform or repository management platforms like GitHub or AWS CodeCommit or Bitbucket or GitLab, which we have discussed in previous section. Remote repository is like shared space accessible to multiple contributors. It's where you store your project online, allowing others to view, contribute to, and collaborate on your work. While repository management platforms like GitHub, Bitbucket, CodeCommit are popular choice for hosting remote repositories. A remote repository can essentially be any Git repository that is hosted on a different machine or server from your local repository. It could be a self-hosted server, network, drive, and so on. In essence, your local repository is your private workspace, while the remote repository hosted on platforms like GitHub, AWS CodeCommit is the shared hub where everyone collaborates and share their works. Understanding the relationship between these two repositories is crucial for effective collaboration and project management in Git. In summary, we have installed Git on our local workstation and made our initial commit using the locally installed Git. However, all our code remains confined to our local workstation at this point. To make it accessible to multiple collaborators and securely store it on remote server, thus reducing dependency on single point of failure such as our workstation, we will set up and utilize remote repository by pushing our code to it. So let's begin by signing up on GitHub followed by setting up CodeCommit. If you're joining an existing organization with an established code base, the organization will provide you with access to their remote repository platform, which could be GitHub, Bitbucket, CodeCommit, Azure DevOps, GitLab, or another similar platform. In such cases, you don't need to worry about signing up for GitHub or AWS independently. Let's begin by signing up on GitHub. I am currently on the website github.com. In 2018, Microsoft acquired GitHub, And GitHub offers both free and paid plans. In their free plan, they are offering unlimited public and private repositories, automatic security and version updates, and some advanced features. And today we are going to join the free plan of GitHub. So to sign up, you just need to provide all the details and verify account. And once verified, you will most probably land on the dashboard page. And here we will create our first repository. Now we will create and add new file to our repo. And to do that, I am clicking on create a new file button link here. I'm gonna name my file hello world.sh and just add one simple print statement and say commit changes. And on this window, you can add your commit message. And as we discussed earlier, it's recommended to add detailed commit message so that later you will know why that commit was made, and say commit changes. And that's it. We made our first commit in GitHub. Earlier, we have seen the same process from command line. And this time we committed from GitHub UI. Now that our remote and local both are ready, we will look into how we can pull changes from remote to local and push changes from local to remote. In this case, our local is our local Git, which we have installed and made one commit locally. And the remote is GitHub. So now that we are on GitHub and our repository is ready to pull from GitHub to local, we will start from pulling the changes from remote to local first. And in order to do that, we first need to authenticate our local Git, somehow prove to GitHub that we are legitimate user. And for that, we need to create a token. So if you try to use username password, which we use for GitHub, that will not work because of security reasons. GitHub recommends to use token instead of password. So to generate token, go to settings. So you can go to settings by clicking on your username and then go to settings and then look for developer settings. In there, you will see personal access token and we will create classic token. Here, I'm gonna generate new token using classic, and I will add a note which will later help me understand why I had created this token. So I will say token for demo. And you can select expiration period. So it could be 7 days till you can even set no expiration. For now, I'm going to set 7 days. And we also need to select the scope for the token. So for now, I'm selecting repo because rest of the operations are advanced ones. So I'm just going to select the repository. And that's it, generate token. So my token is ready. I'm gonna copy it. After that, go back to your repository and we need URL to clone the repository on our local machine. So when we say git clone, that means we are just pulling or copying the repository from remote to local. So I'm gonna click on the code, and there are several ways you can clone the repository. You can either use HTTPS, SSH, GitHub CLI, but in this demo, I'm going to use HTTPS. So I'm going to copy the link and go back to my terminal. So I'm at the root of my projects where I am working on different repositories. And here I'm going to type git clone and the URL and press enter. It will ask for the username, and password will be our token which we had generated, and enter. And there you have it, your repository from GitHub to local. So that's how we pull the repository from remote to local. Now, in our previous step, when we install our Git, we had created a repository and committed one file. Now let's say you want to push that repository to GitHub. So let's go into that repository first. And here is our file or repository which we had created earlier from our local. We have one commit in this repo. In order to push our changes from local to remote, let's first create a new repository. I will name it my locally created repo. I will keep it private and create it. If you check here, there are instructions provided how we can create a new repository on command line. So we have from command line, we have already done till this step, git commit. Now we just need to add the git remote, and this is the command to do that. Git remote add origin and the URL. So I'm gonna go back and execute that from my terminal. Now our remote has been set to our GitHub repository, and then I will use the git push command to push the changes to remote. And the command is git push -u origin main. So origin is our remote which we have set in our previous command, and main is the branch. We will talk about branches shortly, but this is the branch where we are gonna push our changes. And that's it. So if I go back to GitHub and refresh my repository, I can see my file checked in or pushed to the remote, which is Git. So that's how we pull and push changes between remote and local. I will quickly walk you through setting up CodeCommit in AWS. So you will have choice either to use either to use GitHub or CodeCommit. So let's quickly do the setup in CodeCommit as well. So in order to use CodeCommit, you first need to log in or register to AWS. And to do that, I'm gonna visit AWS Amazon.com website and say create a new account. And again, you have to fill in all your details. You need email address and you can name your account. Once you verify your account, you need to set up your root user password. On next step, it will ask you for more details. You need to fill them up. And then it will ask you for billing information. So basically it will ask you for credit or debit card details. They will not bill you because we are gonna use AWS free tier. However, they need card details just for security. So once verification is done, you need to select a support plan. We are gonna go with the free one and say complete sign up. Now we need to go to the console. So once you're on the console, make sure that you have chose the right region. For me, it's Canada Central, so I selected that one. And now to access CodeCommit, you can either type CodeCommit in the search box and you will see CodeCommit here, or you can go to the services and search for developer tools, and under developer tools, you will find CodeCommit. You may get directed to this page. When you create new account, it may take up to 24 hours to get your account fully activated. So if you see this page, you may need to wait and revisit later. So my AWS account has been activated. I'm gonna go and create a new repository, and description and tags are optional, so I'm just go ahead. So now repository has been created, and to clone this repository on our local workstation, we have a couple of options. Either we can use HTTPS or SSH or HTTPS with gRC, and these options are pretty much standard for all repository management platforms. So today I'm gonna use HTTPS, and for that I'm gonna just clone the URL. To copy the clone URL, click on the clone URL and select clone HTTPS, and that will copy the URL. So after that, go to our terminal. Make sure you are at the right location, and then type git clone and the URL. Paste the command and press enter, and it will ask you for username password. So in order to get username and password, we need to go back to AWS console. So once you are on AWS console, go to security credentials and then click on user, create a new user, and I'm gonna keep this user very simple. Add permissions, and I'm gonna add administrative permissions. It's not recommended, but just for a demo I'm going with full access, and create user. So once user is created, make sure to copy and note it somewhere, or you can also download .csv file for later use. After that, go to user and then go to the tab security credentials, and under security credentials, look for HTTPS Git credentials for AWS CodeCommit. So there are several ways using which we can clone the repository, but today we are going to use HTTPS, and that's why we are going to create the credentials for HTTPS. So generate credentials, and again make a note of username and password, or even you can download credentials and go back to your terminal. So these are the credentials we are going to use to clone our repo. I'll just copy paste my credentials, and it worked. So let's add some file into our repo. So first of all, let's see our repository. So when I say ls, I can see demo CodeCommit repo. That's the repo which we had created in CodeCommit and pulled on our local workstation. Right now the repository is empty, so let's add a couple of files in there. I'm creating a couple of files. So I have 3 files created. As we already covered, we need to stage, once the files are created, we need to stage them. And to stage the files, we can use the command git add. You can either separately mention all the files which you need to stage, or if you want to stage all of them, then you can say git add dot, and that will add all the new files available in the current repository or current directory, and enter. Then so all our files are now staged. Now we need to commit the staged files, and for that we are going to use git commit -m and commit message. And all 3 files are now bundled into one commit and ready to push to the remote. In order to push our new commit, I'm going to use git push -u origin main command, and let's go to CodeCommit to see if our files are now there in the repository. So CodeCommit, and I'm going to my repository, and yes, all 3 files are there. So we have pushed our files from local to remote. In summary, we have seen 2 approaches making changes to your project. Either create and push changes from your local workstation to the remote repository, or make changes directly on remote platform. In the second case, you don't need to push your changes anywhere because they are already applied to remote repository. Working directly on remote repository might seem easier at first. However, when you start working on your code using code editor on your workstation, pushing changes from local to remote proves to be more beneficial and efficient. So in general, you can access and interact with Git repositories through various methods. And the 4 main ways are command line interface, repository management platform like GitHub, CodeCommit, GitLab, Bitbucket, integrated development environment or IDE or code editor such as Visual Studio Code, Eclipse, Git client like SourceTree, GitHub Desktop, and so on. So far we have seen first 2, command line interface and repository management platform, and in repository management platform we saw GitHub and CodeCommit. These methods cater to different preferences and workflows, and developers often choose the one that aligns with their proficiency and specific project requirements. Today, I will guide you through my preferred IDE, which I use for coding on daily basis, Visual Studio Code. Developed by Microsoft, it's a free tool that's compatible with Windows, Linux, and Mac. You can easily download it from code.visualstudio.com, and installation is straightforward. We will establish connection from Visual Studio Code to our remote repositories hosted on both GitHub and AWS CodeCommit. Beginning with GitHub, after launching Visual Studio Code, navigate to the Explorer tab, and there you will find clone repository. So default it will ask if we want to clone from GitHub. If you click on it, it will ask you to authenticate. So you have to authenticate Visual Studio Code with GitHub's username and password, and then you will see then Visual Studio Code will automatically display all the repositories you have in your GitHub account. So right now I have 3 repositories in there. I will clone the repository with name my demo repo, and we have to select where on our workstation we want to install it. So I'm gonna select my folder, and I said yes, open the checked out repository, and I will also say yes, I trust the author. And now our repository is already checked out on our local workstation. So now let's see how we can make a change, because as I said, Visual Studio Code is a code editor. You can use it to make changes to your code and push those changes back to the GitHub or CodeCommit. So I'm gonna show you one simple change. So if you click on the source control, you will see all the changes for that particular repository. So here there are options. So if you remember from command line, we use git add command to stage our changes. In Visual Studio Code, you can use this plus sign. If you prefer to use command line from Visual Studio Code, you can also click on the terminal, new terminal. You will get the command line terminal from Visual Studio Code as well. But I will show you how to use it from the GUI. So you just click on the plus sign, and that means our changes are staged. And to commit the stage change, you click on the commit button. From GUI, from CLI, we use git commit command, but from Visual Studio GUI, you just press the commit button, and then it will ask you to provide commit message. So I have added the commit message. I'm gonna save it and exit. And now my change is ready. So far we have worked on local workstation, and when we want to push our changes, as we have seen, we use git push command. So here we are just simply gonna say push, and it will push to the remote. So yeah, we have successfully pushed our change from our local workstation to GitHub. And to see that change, we will quickly go to GitHub and check if that change has been reflected or not. I am on my GitHub account, and I'm gonna go in the repository where we have made the change, and I will open the file, and you can see the change. You can also check details of the commit, like what was the commit ID, when the change was made, and so on. Now let's quickly take a look how we can connect CodeCommit repository with Visual Studio Code. I am in source control of Visual Studio Code, and there I'm gonna click clone. And this time we are not going to clone from GitHub, so we need a URL. So to get the URL, I'm going to my AWS account, and I'm gonna type CodeCommit. Always make sure you are in the right region. And this is my repository. I'm gonna copy the clone URL and go back to Visual Studio Code. Clone, and then I will enter my URL here and press enter. I will choose where I wanna clone the repository, and then it will ask me for username and password. And it's asking me if I wanna open my clone repository. I'm saying yes. I have created a separate folder named CodeCommit to store the code from the CodeCommit. So I'm gonna select that, and here I see my files from the CodeCommit, and the check-in process is same as we seen for GitHub. So you just need to enter your change, save it. You will see that here. Click plus to stage it, click commit to commit it with some message, save it, and then push it. and let's check it on our code commit. I'll go to commits. Under commit tab, you will see the history of all commits. And here we can see our latest commit. If you click on it, you will see details like who was the author, that means who made the change, when that change was made, and commit ID, commit message. And if you go down, you will see, you will also see the differences. What was the change made? So if it's plus sign, then that means this line is newly added. So let's say if you remove a line, then you will see the minus sign with that line removed, and you can browse through the changes. Now let's talk about branching in Git. I'm going to use diagram from Atlassian site to explain Git branching. Branching in Git is like creating separate paths in your project's development journey. Imagine your project as a tree trunk, and branching is like growing new branches from it. Each branch can have its own changes and updates without affecting the main trunk. It's a way to work on different features or fixes independently and then merge them back into the main project when they are ready. Branching helps keep your project organized and allow for collaboration without interfering with the main code base. The main branch, often named main or master, in Git serves as the fundamental trunk from which all other branches are created. When you are working on a new feature, bug fixes, or any other modification, you typically create a separate branch. This separate branch allows you to make changes without affecting the main code base. After making changes on separate branch, you verify that they work as intended. Once you have thoroughly tested and confirmed the changes, you merge them back into the main branch. This process ensures that changes from other branches are incorporated into main code base, maintaining its stability and integrity. In essence, branches are used for developing new features or fixing issues, while the main branch remains stable foundation of the project. Now let's look at couple of Git branch commands. We will start from the Git command line, and then we will also look into how to create branches from Visual Studio Code as well as GitHub and CodeCommit. I am inside my repository, and let's say if you want to see the list of all available branches on your repo, then you just need to use the command git branch -a, and it will show you all the available branches. So currently I have only one branch. Also, in case you want to check on which branch you are currently on, you can use git branch command. That will show you the current active branch. To create a new branch from command line, you have to use git branch and then branch name. So feature 1 will be my new branch. I will again check the list of all branches, and now I can see feature 1 added to the list. And I want to see on which branch I'm currently on. I'm still on main, because when you create branch, Git does not change the branch. In order to change the branch, you have to use git checkout and the branch name, and that way you will be able to switch the branch. And now my active branch is feature 1. The active branch has the star. If you want to combine branch creation and switching in one single command, then you can use git checkout -b and the branch name. It should create branch feature 2 and also switch my branch to feature 2. And if I want to go back to my main branch again, then I will do git checkout main. To delete the branch, we can use git branch -d and branch name. Now let's take a look how to create branches from Visual Studio Code. I will go to source control and then click on these 3 dots, and from here I will go to branches and then create branch, and I will type my new branch name feature 3 and enter. and this way the new branch will be created, and you can push the newly created branch to remote just as you push your code changes. Now let's take a look at the GitHub branches. So I'm going to my repository. Here you can see your currently active branch, and if you click on the drop down list, you will see all the available branches and tags for that particular rep. Now to create a branch, I'm gonna click on the view all branches. On this page you will see all the available branches, and to create a new branch you can click on the new branch and give your branch a name, and you can also select from which branch you want to create this new branch. So I'm gonna keep main, and that will create a new branch. You can switch branches from here. So from main to, you can select feature 3 and the code will be updated. And to delete the branch, again you can just say delete. And lastly, let's take a look at the AWS CodeCommit. So I am in my AWS CodeCommit repository. Here you will see branches tab, and on this page you will see all available branches. To create a branch, say create branch and the branch name, and you can also select from which branch you want to create this branch, and the branch will be created. To delete the branch, you can just select the branch and say delete branch. And let's say if you want to switch the branch, then when you are in the code, just change the reference to the different branch. Let's use a diagram to go over the process we have seen so far. So here is the developer's local workstation. Developer can choose to either work with Git command line or use code editor tool like Visual Studio Code. There is the remote repository, and it could be GitHub, AWS CodeCommit, Bitbucket, or any other similar tool. If you are creating the repository first time from your local workstation, then you need to use git init to initialize repository and then push it back to the remote. But let's say if you want to make a copy of existing repository which is present on remote to your local workstation, then use git clone. Using git clone, you can copy the remote repository to your local workstation. Once you have copy of repository, you can choose to create a branch so that you can work on your feature without impacting the main branch. Once you create a branch, and if you are working with multiple developers, then it's a good idea to push your branch back to remote so that other developers can also access that branch. Then from your local workstation, you can keep working on your local branch. You can keep editing your code, saving it, and you can even work with multiple files. And once you are satisfied with your code changes, you can bundle all your changes into one commit by first staging it and then committing it to your local Git repository. It's recommended to periodically pull the changes from remote to local, especially if you are working with multiple developers, so that you will get their changes as well, and later you will avoid the conflict. Then you can push your commit to remote, and that commit will be on your new branch. So you can push that to your remote server. That way your changes will be available for others to see and pull. Lastly, let's discuss the concept of a pull request. In Git, pull request represents a formal request to integrate changes made in one branch into another branch. This mechanism is frequently employed in collaborative software development settings, particularly when utilizing repository hosting platforms such as GitHub, CodeCommit. The process begins with a developer branching off from the main code base to work on a specific task, such as implementing a new feature or fixing a bug. As the developer progresses, they commit changes to their branch. Once the changes are considered complete, the developer opens a pull request, signaling their intention to merge the changes into the main branch. This pull request acts as a gateway for peer review, allowing other team members to provide feedback, suggestions, and ensure code quality. Through discussions and code reviews, the team collectively ensures the integrity and functionality of the proposed changes. Additionally, automated tests or manual testing may be conducted to validate the modifications. After thorough review and approval, the changes are merged into main branch, incorporating new feature or bug fix into the project's code base. Pull requests thus play a crucial role in maintaining code quality, facilitating collaboration, and ensuring a structured approach to integrating changes into a project. Now let's see how we can create a pull request first in the GitHub. So we have two branches in our repository, main and feature 3. I'm first gonna make a couple of changes on my feature 3 branch. I'm gonna add readme and commit my changes. Now that my feature branch is different from main branch, I'm gonna go ahead and create a pull request and say create new pull request. So here I want to merge feature 3 into main. And once I select that, I'm saying base will be main and I want to merge the feature into main branch. If there is any conflict, then this UI will let me know about that. Right now there is no conflict. It is saying able to merge. And it is also showing me the differences, what is gonna change if I merge my feature 3 into main. As we know, we had created a new readme file on the feature 3 which was not there in the main. If I go ahead and create a pull request, it will ask me about the description, why this pull request was created. So to add readme, I'm gonna just add some simple description and I will say create a pull request. So while creating a pull request, you can also, and reviewers could be your colleagues or peers, they can take a look at your code changes and let you know if there is any issue. They can take a look at your code changes and approve it if everything looks good. So right now there is no conflict and I haven't added any reviewer, so I am good to merge. But let's say if you add any reviewer, then until and unless they don't approve it, you won't be able to merge it. So let's go ahead and click merge and confirm the merge, and merge is done. So if I check my open pull request dashboard, there is no new request available. And if I go back in the code, then on my master branch, I can see the readme.md file. This is how you do merging of code changes using pull request. Similarly, we will see how we can create a pull request in CodeCommit. So in CodeCommit, you will see a pull request tab, and if you go on pull request, say create pull request, you can select the destination, which is main, and source is feature, because we want to merge code changes from our feature branch to main branch. And when we click on compare, it shows us the detail view. There is no new change in my feature branch, and that's why there is no difference in the comparison. But just for a demo, I'm just gonna go ahead and create a pull request. Once the pull request is created and once you have all the required approvals, you can just go ahead and say merge, and that will merge to the main branch. So on this page, you can select type of merge. So I'm gonna keep fast forward merge, which is the default one, and I'm also gonna select the delete source branch after merging. So it helps keeping our code base clean. So once we are done with the branch use, we can go ahead and delete it. So I'm just gonna say merge the pull request, and my pull request got merged into the main branch. So basically this is the basic idea about how you can create and merge your code changes into the main branch. Now let's look at couple of useful Git commands. To view the commit history of the repository, you can use git log command, and to use this command you first need to make sure that you are inside your repository, and from the repository you can type git log, and it will show the history of previous commits. Similarly, if you need help or more information about a git command, You just need to append --help to the git command, and it will display all available options related to that command. So just to give an example, let's say I want help with git add command, then I will type git add --help, and it will show what all options I can use with my git add command. Let's say you are working on a file and you made some changes, and now you want to see what changes you have made but not yet committed. Then you can use git diff command. So let's say I have a file 1.txt here, and I will just add some text here. I'll save it, and now if I use git diff, then it will show me the difference. So this line has been added, that's why the plus sign has been prepended to the line, which is showing the addition of new line. If I remove the line, then it will be a minus sign, and that's how you can see the differences locally. Thank you for watching. If you found the video helpful, please consider liking and sharing it with others. And don't forget to subscribe to my channel for more tutorials like this. See you in the next video.